Let's take a look at a problem involving drug testing. This is a problem where we're going to assume either athletes have used performance-enhancing drugs or they've not used performance-enhancing drugs, and then they will be tested for those things to either test positive or negative. These tests aren't perfect, and so these probabilities are going to be reflected here. So it says the probability that an Olympic athlete that has used banned performance-enhancing drug is 5%. An athlete at the Olympics is suspected of using a banned performance-enhancing drug. The officials administer a drug test to the athlete. If the athlete has used the banned performance-enhancing drug, the probability that the test is positive is 90%. If the athlete has not used the drug, the probability that the athlete still tests positive is 1%. What is the probability that the athlete has not used a banned performance-enhancing drug and tests positive? So let's take a look at what our tree diagram is going to look like. So we're going to start out and say they're either taking the drug or they are not taking the drug, the complement of that. So this is taking drug or not taking drug. Now, if they're taking the drug, they could test positive or they could test negative. Same thing if they're not taking the drug. They could test positive or they could test negative. We need to label these different branches using the information in the problem. So it said the probability that an Olympic athlete has used a banned performance-enhancing drug is 5%. So that means the branch going up to D is going to have the probability 5% or 0.05. And that is essentially telling me that's the probability of D. Now, along the other branch on the other side, that's going to be the probability of not taking the drug. And if the probability up here was 5% or 0.05, down here, it's going to be 0.95 or 95% because you either do one or the other, right? These have to add up to 1. All right, we also have down here, if the athlete has used the banned performance-enhancing drug, that means they're at D, the probability the test is positive is 90%. So if we start at D and go up to positive, that is going to be 0.90. So that is the probability of testing positive given that they took the drug. So if that probability is 90%, the likelihood of testing negative, given that they're on the drug, is going to be 0.10. The other information we had down here is it said if the athlete has not used the drug, so that means they're at the complement of D, the probability that the athlete still tests positive is 1%. So that means the branch that goes from the complement of D up to positive is 0.01. So the other one is going to be 0.99. So now that we have everything labeled here, we have to go ahead and figure out what it is they want us to find. So it said, what is the probability that the athlete has not used performance-enhancing drug? So that would be the complement of D, and they test positive. That's the probability we want. And that corresponds to the branch that goes to the complement of D and then up to positive. So what essentially we have to calculate here is we have to take the probability of the complement of D and we're going to multiply that times the probability of positive given the complement of D. And those are just the probabilities along the branches. So 0.95 times 0.01. We multiply those two together. We get 0.0095. So there's less than a 1% chance that they have not used drugs and they still test positive. Remember, when you're following a branch, you're always multiplying the probabilities, and that's what we did in this case.